你好，认识你们很高兴。But the rest we're going to do in English. I don't mind. I'm sorry. Except I can do it in French, of course, to prefer English. So, in the next couple of days, you're going to hear very deep technical talks about a number of topics and a number of technologies. And that is good because that means I don't have to go deep into technical details for a short introduction. I thought I would take a step back, review the web platform as a whole through 4 different stories, media-related stories, so that we can, extract some commonalities, kind of more aspirational and vocational story. That would, in the end, if I manage to convince a couple of you, either in this room or, following the broadcast, that standardization is fantastic and that it requires, some investment, some passion, that would be fantastic. So, the 4 stories I'd like to, 4 media-related stories I'd like to tell. One is media, so traditional media streaming area. The other one is games. The third one is AI, and the 4th one is the metaverse. And so they are a bit different, but in the end, I'd like to, bind them together and see how they are coming. So let's start with media on the web. And of course, media is not exactly a new thing. It has been around for a number of years. Even before it was on the web, it was already on the web somehow through plugins. So we've been experiencing media on the web for a very, very, very long time. And for in HTML, the way it got standardized is through the audio and video tag that you may be familiar with. And we've done it initially in some sort of traditional media distribution way. I think it's no longer really current, so that's why it's not really today, maybe yesterday. It depends on where you are and how you are experiencing media, where you are on Earth and how you're experiencing media through your applications. But the fact is, usually the way we approach media is you fetch media somehow, and then you're going to use usually media source extensions or MSC. To go through a simple pipeline that ends up in your computer being rendered as a media player, playback, and you get media. And that worked well. It took a number of years to get for us to get there, to get agreement between different players. And that trend is still ongoing. We're still addressing things. Because we've been telling a fantastic story on MSC, for instance, on media source extension, saying it's been supported everywhere except on one platform. If you're trying to do MSC on iPhone, it doesn't work. And the reason it doesn't work is that Apple has never been satisfied with MSC on iPhones because of the constraints of the device, and they wanted something else. So this something else is something we're currently adding to MSC. It's called Managed Media Source. It's a sort of intermediary level between the previous media source and the new one that gives more control to the device so that it can, find the right, it can tune the battery consumption settings, for instance. Another area, so there's still a bit of device fragmentation with media because the capabilities are extremely different from one device to another. So we're trying to expose that with the media capabilities specification. And so there are a number of things that are, improving slowly over time. It's ongoing. One thing we're trying for years is support for second screen. Each time we go to a room such as this room, for instance, there's a kind of, very complicated setup where you need to bring your laptop to connect to the screen and so on. Whereas actually we all have the technology we need on our device. I'm sure this device, this screen can remote control it pretty easily. But for that, we need to agree on an open set of protocols and not proprietary solutions, because proprietary solutions, reduce the interoperability we can get, especially between devices. So we're trying to push in that direction, but that takes time. So that's ongoing evolution of the traditional way of streaming media on the web. But at the same time, the trend that has been occurring in the past few years is to take all these traditions to change the way we approach media streaming, and rather to approach it from a real-time angle. And so, of course, that starts with enabling real-time communications on the web with the WebRTC stack of technologies. And in that area, China is extremely advanced. Actually, each time I go to China, I'm impressed, because you have advanced scenarios that we don't really do in Europe, at least. Live broadcasting come to mind, for instance, and we don't really do that elsewhere. But you do that, and it works. And the way it works is you really mix WebRTC technology with traditional media broadcasting technology to take the best of both worlds, reduce the latency of distribution, and so on. And so you can imagine plenty of things that can lead to engaging experiences in the end. There are a few open questions there. One of them is codecs. Codecs remains a huge problem from a web perspective, because there are plenty of them, and they all have some kind of restricted licensing conditions, which make them difficult to use directly on the web, and it makes them it makes it difficult to impose any particular codec on the web. So in the future, what we're seeing is that the web is currently evolving toward a mode where the application is taking complete control over the media rendering, and that means in the end, it's even if we're back to the 19th century or the beginning of the 20th century, where we're going to have each frame and we're going to render them individually, one after the other, and that creates an animation, and that creates the impression of media playback, and that will be done by the application. It's one possible evolution, and that's being enabled by the different technology that you're going to hear about in the next couple of days. So that's one story. Moving to the next one, which is about games. And same thing as media, games is not exactly a new thing. We've been playing games on the web since since the web started, essentially. Initially, same thing. It was through plugins. In this case, it was through Adobe Flash, that we had plenty of entertaining experiences back in the day, that some of you are too young to have experienced that. And from a standardization perspective, same thing. I've been exploring that space for some time. I organized the first standardization workshop back in 2011. At that time, it was, HTML5 was cool. We had a fantastic new logo, and we were exploring that space. And we had plenty of discussions that led to some extent to work with standardization work on the gamepad API, on full screen, on pointer lock, on workers, and then all the technologies I already mentioned. So that's, again, not new. But what I wanted to mention is that games are extremely interesting. Well, first because they're entertaining, of course, they're fun, but what is very interesting is that they always push platforms to their limits. You always want to have precise control over everything when you develop a game. And so it's always a fantastic driving use case to push technologies forward. And I organized the second workshop in 2019, and that was more around, the focus at the time was more around cloud gaming, and that was when web codecs and web transport were initiated. Even though web codecs and web transport are used now for other things, one of the driving use cases again was games. So what do you want to say about games? They have the web games. It's funny, if I look at the history, the web games, it goes up and down. From time to time, people are crazy, they jump on web games and they say, oh, that's a fantastic platform, let's develop a game for the web. And from time to time, they say, oh no, that's a terrible platform because you can't, you have problem with loading time, storage is a mess, mixing content is problematic, especially with the security problems. It's a feature on the web security, but it's a problem when you want to do advanced things. And more importantly, discoverability is hard. There's no easy way to monetize content on the web. You're basically going to do it through ads, but it's not necessarily satisfactory if you want to resell something. And the reason why it doesn't work easily is that you're not tied to one application store on the web. You can distribute your game wherever you want, which is actually a strength as well. But it's a strength, and if you want to reach millions of people, it's also a weakness. So there's a number of things that makes web games go up and down. Recently, we have been discussing. Folks were at the Games Developer Conference that was organized in March, I think, this year, and they reported that actually they saw renewed enthusiasm for web games, especially because in my list of this no install step, and users are getting tired of installing applications, and the web for that is a fantastic platform because you click on a link and you start the experience. You don't have to install anything. And so there's a community group in W3C, which is, an open discussion forum that discusses things. And, you're most welcome to join. And the group doesn't develop technical specs, but it tries to look at the technical specs and to understand whether there are gaps that could be filled and whether there are requirements that could be brought to different technical groups within W3C. So that's my second story. I'm moving forward in the interest of time. Third story is the artificial intelligence. And same thing, it's not exactly a new thing. When I was young, we were talking about neural networks already, and it went very slowly. I guess progress went slowly because long time ago, GPUs didn't exist, so parallelization was not necessarily a thing, and with neural networks and all these machine learning models, you really want parallelization computing, otherwise it doesn't really work very well. So from the standardization perspective, again, we usually start with some kind of standardization workshop, and so we had one in 2020, that led to the work on this machine learning API called WebEvolve, and we will hear about WebEvolve today, I think. There are a few other APIs that surpass machine learning models on the web. But that's the first context, the long-term evolution of the web in the sense of AI has been around for some time. We've been looking into it and we're trying to enable it. At the same time, of course, you have all noticed that we are experiencing an AI revolution right now. It has boomed, it has exploded, largely due to large language models and so-called generative AI. And these large language models create a number of issues. They are usually trained on content. The content is public content, and the best platform to get public content is the web. You have plenty of public content at scale, and so you can train on it. But then it has plenty of biases, plenty of conceptual issues, hallucinations. I find it funny that I try to prompt a generative AI system. Draw me a picture of an AI that is hallucinating, and the response is an exploding human head. So probably that means the biases of the AI are also the biases of the human behind them. It's a bit we're looping on different concepts. It's interesting. It's highly philosophical, I suppose. Anyway, there are plenty of risks associated with AI. What we've been doing at W3C, so right now, especially in the context of this new revolution, is we're looking into it. We the team, technical team, are trying to study analyze the landscape And we've published a short report, which really is an internal. It's not an internal report because it's public, but internal in the sense that it's just the consensus of the W3C team and not the consensus of the W3C at large. But it's meant to highlight the systematic impact of AI systems and highlight a few directions that where we could go, a few standardization directions that we could tackle in the short term or mid-term. Some of which are listed there. That includes a consent mechanism. For instance, if you publish content on the web, you may not want the content to be used to train artificial intelligence, and perhaps if you had a way to specify that, that would be great. If you don't want your AI to be trained on content generated by another AI, you may want some kind of labeling of the content to take place, because otherwise you're going to look through AI-generated content, which is a bit weird. So there are different directions. I'm not going through all of them here. Same thing, I think you're really clear about this. AI has, of course, a huge environmental impact due to the computation that it requires and generates. And so we may want to look into that. So it's really a scaling issue in the end. And from a standardization perspective, AI triggers an interesting problem. Usually when we develop a spec, we try to ensure that the implementations are interoperable. But if the spec actually leaves it up to browsers to implement their own machine learning models behind the API, in some kind of API, there will be differences. If you give the same picture to the face recognition API, for instance, you give the same picture to Chrome, to Firefox, to Safari, you won't get exactly the same result. And what does it mean in terms of interoperability? So that's the kind of standardization question that we have. So that's my third story, and then the fourth one, and then wrap up. I have a number of slides, but I'll go through them quickly. So the fourth one is the metaverse, and the metaverse means essentially anything, but it means we're going to experience things naturally in a virtual world, which actually is not completely virtual, it's also physical, it's a mixed world. We'll have natural interactions, we'll have a magical world, and we will be able to do everything. Fantastic promise. If you look at it from a technical perspective, well, you can do some of it on the web today. You have the technical foundations you need, and we're working on the missing bits today. So if you need to render 3D, you can do it through WebGL, for WebGPU, for sharing language. For audio, you can use the WebEvolve API. For XR headset support, we have the whole family of specifications. We are now really working hard to expose computing powers to applications. And of course, I already mentioned real-time communication with WebRTC. So we have all the technologies, the foundations that we need. Some people add a number of other technical needs when they think about the metaverse. Usually it's called Web3. It has some blockchain in it. It has some economy, money involved, and so on. I don't know if we need to worry about this to really enable the metaverse, but that's my personal take. But what is sure is that once you have the technical foundation, actually you open a Pandora box, and the number of technical needs that you have that suddenly start to emerge. Some of them are listed there. A way to describe, an avatar from an immersive experience. I need to be rendered somehow. Some user interactions in an immersive environment are not standardized yet. I mean, we can point at things, but then it's not inspiring. Apple introduced a new paradigm where you just sitting and you look at things and you pinch your fingers. That's a different way to interact with content. So there are lots of technical needs that go beyond foundation there. And if you really start imagining a world where we have a metaverse, well, you have plenty of problems that arise with that, especially if we just build on the technical foundation that we exposed. Yeah, that means I need to hurry up. And so the way I view the metaverse to me is as an evolution of the web and not as something different. And if it's an evolution of the web, it needs to follow the same core principles. The core web principles are usually listed, and the main ones are there. It's accessibility, internationalization, privacy, security, and ubiquity. And the way it works is that your browser is the intermediate between content and users, and the browser is the thing you trust. It's your user agent. That's why we call it a user agent. It's the bit you trust. And if we want the metaverse to become a thing, we need to keep that level of intermediation somewhere, somehow. And that's not necessarily easy. I'm not going into details in the interest of time. What I wanted to say is that the web currently is just 1D content. It was designed for textual linear content. HTML is just linear. We just love linear. That's what the web does best. It's 1D content. And of course, we, over time, added things to handle 2D content. So tables, images, videos, canvas, that's things you can use to lay out your content in 2D. But each time we have some kind of notion of text alternative. So we get back to 1D whenever we can. And the important thing to note is that the web does not understand anything about 3D. The way you use 3D on the web is you have a canvas and you draw your own pixel. We're just helping you with WebGPU, but they are graphics rendering API. They are not 3D APIs. The browser never knows that you're rendering a 3D object. It just knows that you're rendering triangles. For XR experiences, it's exactly the same. We have a family of specifications, but these specifications are just, we give you 2 canvas to the application, and you control, the one is the left eye, the other is the right eye, and you control what you render, the pixels you render, and if you do your work correctly, you're going to end up with a 3D, looking experience. So the problem, of course, is that the user agent doesn't know what gets rendered, so it cannot help with accessibility, it cannot help with internationalization, it cannot help with the core web principles I mentioned before. And currently, web browsers are really 2D user agents at hand. And if we want the metaverse to become a thing in the future, they will need to turn into 3D user agents somehow. And it's not clear that they want to do that today. 3D text, it depends. We're not living in a 3D world when we're not, browsing the web in 3D today. So something needs to change. It may be new devices, it may be new experiences, because we suddenly all have a 3D screens that we start to use as 3D screens. I don't know, but for something to happen, we need things to change. So there's still a trend towards 2.5D, whatever 2.5D. Of course, it's just a nickname with a few proposals that are on the table to trying to make the user agents render more than just 2D, understand more than just 2D. And then later on, we could try to think of converging on 3D formats, perhaps, or addressing a number of other parts. And very quickly, because first you will hear a technical discussion on that, one way to address that would be to describe what we call the one web vision for the metaverse. If we can describe that vision, we'll probably be able to make progress in the right direction. So anyway, what's common with all these 4 stories? Because I've been talking a lot and too much on the different things. What's interesting to me is that from a web platform perspective, they all go in the same direction. They all move towards lower level primitives. So WebAssembly gives you, what I would call native CPU performances. WebGPU gives you access to GPUs. WebConnect gives you access to hardware and software, media encoders and decoders. WebEnds to different chipsets that you have at your disposal in your device to, harness machine learning model. WebXR gives you access to headset, WebRTC Web Transport to as broad network access as possible. So we really have the move towards lower level privilege on the web, triggered by all these different stories like and the problem, or maybe it's not a problem, but the one consequence of that is that there is growing complexity everywhere. And the fact is, for instance, for GPU, no one is going to use web GPU directly in practice, and users are going to probably use an intermediary library to use WebGL or WebGPU is the same thing in the end, because it's too complicated. So for your logic, if you want to really develop an app, you need something simpler. And so there's a trend towards using intermediary libraries there, and it shows that we're adding a lot of complexity to the platform. And complexity leads to frustration. There's always a feature that an API doesn't really support because it's too low level, because there are too many things, too many settings that could be exposed, and we need to find a common ground. So that makes developing for the web a bit harder, and at the same time it creates frustration. These whole story have in common that we no longer need just one API. You need to mix a number of them together to create your experiences. Of course, the equation is completely wrong. It doesn't mean anything, but it's just to show that there's you have plenty of dimensions to take into account. And in the end, we need to balance all the needs to move towards lower level access. We core web principles that are really core to our heart, at least at the W3C. We really want to insist on accessibility, internationalization, privacy, security, and what I call ubiquity, the availability across devices, and that's not easy. So, the conclusion here is that in order for things to work, we don't need to relax. It's going to take time. We need to be zen. We need to look forward at the horizon, and we need to have lots of discussions. And that explains why it takes so much time to get additional technologies. It's very easy if you're single, if you're on your own developing a technology. You may be able actually to develop a fantastic technology that is better than the startup we're going to end up with. But the difficulty with standardization is convincing everyone, is putting everyone around the table, making sure that everyone has the same thing. That's extremely hard. It takes a lot of time, and with the added complexity, that's even harder. But it's even more exciting in the end. So I hope you will be involved somehow in W3C and other activities. Thank you very much. Sorry if I took the time.